All right. So, like I was saying, our intent is not necessary to understand that the computer brings feedback on the screen. There are certain things that are key to us, right? For example, the screen size. How big is the screen? It is very important to us because it helps us to know if the job we are going to do, this screen fits it or not. So, for example, if you are called by a church to build a computer for a specific purpose, let us assume for the accounting part of the church, the screen you need for that purpose is not the same thing as when the church asks you to mount a computer screen or a screen for program projection. So the programs will be projected there, maybe in one of the officials or the director's office. So while he's in his office, he should be able to follow the programs that are going maybe in the auditorium or something like this. So in these two contexts, the screen size might matter, right? The screen size might matter. Good. Then the next thing that might matter to us right now is the resolution. So if you are a computer expert and you are now called to design an image or to design a logo for your organization or your own personal business as a creator, of course, then you realize that when you are on a screen like this, your logo appears well, but when somebody takes the logo on a more bigger screen, then suddenly your logo starts to look like dots, right? It gets what we call pixelated. So it doesn't look fine. And you ask yourself, what happened? So this aspect of the screen is what we call the resolution. So the resolution is kind of the dimension, the diagonal dimension that we have in the screen here. So it's like the ratio of the width by the height. And it determines how sharp a screen can render an image, or a screen can render any thing that it displays. So what it means is, as a computer expert, while you are working, you always care about what screen will give me the sharpest display. Are you getting that? What screen will give me the sharpest display? So it is very important for you. So the resolution matters in the screens. So this criteria is important to us as IT expert. So far we mentioned two, right?
Yes, please.
The first one is the size, as in the physical size. The second one is the resolution. Okay. Then the third one, which is very important for us to consider here, is one aspect of the screens that is called pixels. So right now, while we're discussing the resolution, I mentioned that it is about pixels, or I mentioned that your pictures can be pixelated. So what it means is screens are built on the principle that we call pixels. It is like tiles. Imagine a screen filled with tiles, okay? But this time around, the tiles are not like the ones in the room, which are large enough for you to perceive. The tiles on the screen are very small, are tiny, tiny. We have an article on Init Academy. You could go and check later on. I need to sign in to remove this message. So give me a second to sign in. Okay, so it removes the adverts. So you can see here, you can see we have a lot of people on Init Academy. Can you see?
Yes, please.
Okay, so let me show you the article I was telling you about. It's actually we plan to have a kind of dictionary on the site, but we haven't filled it with a lot of words. But I remember writing about the pixels. So later on, you could come and read about it and go deeper in the understanding, okay, the idea of pixels. So, like this image shows, you can see it is made up of these squares, and each one of these squares has some 3 dots inside, and the 3 dots are RGB, red, green, blue. So basically, for the screen to render anything, it plays with these lights. It creates, I think you did arts in school, so you learned how to mix colors and all these things. So the same thing the screen does. Every single pixel in the screen is this square, each one of these squares, and within within each square there are 3 lights, which is the red, green, and blue. So within the square, these 3 lights can be mixed in different levels to produce a special color that will paint a part of an image or part of whatever the screen is rendering, that text or image. Okay. So what I'm trying to say is this. If I come back on my drawing board, imagine you have a screen with like this. Okay, we'll assume a manual screen for now, and that screen is divided in 4 squares. So each one of these squares is what we call a pixel. Okay, but each one of these pixels can vary its color. So what it means is this pixel here can change its color in a way that it will look blue. Okay, this area will look blue, just like the way you see it on my screen. It's the same thing that is happening. You see, areas of my screen are having black, some areas are having green, some areas are having red, and so on. Just like this area I just painted in blue. So all the pixels right in my screen in this small area, I've just decided to change their color into blue. So then the other one could go green, somewhere like this, and so on. It can be filled or anyhow mounted. Then this one will go brown. Okay. And then we keep the other one white or black. Oh, we get white, so let's go ahead because we have a black screen. Like this. Now, if you were to draw Tom and Jerry on this, so let's say I pick a different color, which is like this. Let's say I am to draw something on this screen, and I'll use my Tom and Jerry. I might decide to say, okay, for Tom and Jerry to appear on this screen, it has 4 squares, and it must appear on, let's say, 2 of the squares. So I could make Tom and Jerry, Tom like this. Although Tom is a mouse, like this. Right? So it is occupying 2 pixels. The same thing, yes. I could draw another one, let's say some kind of horse, that will occupy all the squares. So I don't know if it's like I'm out of colors. I think I can get some dark green. So let me I'm bad at drawing, so please bear with me. So I'm drawing some crazy thing here in green, but it occupies these 4 squares. So just to, oh, it's not visible, unfortunately. So I think I need to look for a better color. So I'm trying to make a car actually. So let's say I put the wheels somewhere here. That's a very bad car. Eh? Good. So something like this. In this case, you can see our car actually occupies the 4 pixels. Now imagine a screen where you have more than the 4 pixels. Okay. In this case now, this screen has more pixels. It means we have more room to display our car and also our Tom and Jerry. So our car could take just a portion of this, like this. Okay. While our Tom and Jerry stays here peacefully. You see, we have more room. But in addition to that, because we can give to each one of our images enough space, then it makes it look sharper. Okay, it makes it look sharper because the pixels are more, they are many, they are more condensed. Then it gives you a sharper image. So the more pixels the screen has, the sharper the image is. And that also involves the size of the screen. So when they say I want a screen with higher resolution, it means I want a screen with a high ratio of pixels. The number of pixels that the screen can have on its horizontal size, which is at the bottom here, compared to the number of pixels it can have in this direction. Then we produce the ratio, and that's the resolution. So if you hear that a screen is 1080, right? Sometimes you see it is 1080 or 1024. You see these numbers as in the resolution. What it means is if you want to count the pixels from here, all the small pixels that are beneath this screen from here and all this, then you are going to have 1080 or 1024. So you can imagine with 4 pixels we are able to render Tom and Jerry and our car. So with thousands of pixels, you can imagine how much you can do. And with this size of the screen as you are seeing in front of you, thousands of them are lined in it. So they are super tiny to the extent that you cannot see. So one good way to see them, if you want to have a sense of it, is to take your phone and try to take a picture of your screen. But instead of you to take a picture, you zoom the screen on your phone. So you zoom to the highest possible. So you will see some reddish, greenish, bluish dots will start to appear if your screen has a good, your phone has good resolution to zoom. As I'm speaking, are you giving it a try?
Yeah, I want to.
Give it a try. Let's see what you see.
I don't see anything.
your phone cannot zoom enough, big enough. Get it close to the screen.
It cannot zoom.
Let me try mine and see if I can take. It's like mine too is having issues. Okay, I think I can see a bit. It actually blurs the screen. It's blurring the screen. Okay, I think I can see a bit at my end with the video rather. So I'll take a short video and send it to you. Okay, I got some few seconds of video. So I sent it on your WhatsApp. You can look at it and see.
Okay.
I wish I had better resolution. So it shows like some small dots here. But if the phone can zoom well, we should see bigger than that. You should even see them as in red, green, blue, so on. So nonetheless, that's basically what I want you to have in mind when it comes to screens, not just as in a monitor. Okay? A computer technician, a computer expert should know more than that. There is a lot we can discuss about the monitor in terms of how it even gets to display all these things in the first place. But these are advanced topics probably we'll have the chance one day to discuss. So with that, we'll close our talk on the screen. So the next thing we have is the mouse.
a question.
Yes, please, I'm listening.
The pixels, is
Yes.
that each box has a color or each box has three colors?
Each box has three colors.
But see the one you drew for Tom and the
Yes.
is it Jerry and the
The
Jerry
car,
and
any
the
of them.
car, it
Yes.
had it has like one color for each box.
Exactly. I said that it becomes one color, and in that case, it means these three colors have. Look at this. What is the chances that this box becomes blue? This box here. What will make it look blue? If only we dim this red and this green to nothing, right? So if we dim the red
Yes.
and we dim the green completely to the lowest appearance of it, right? To the lowest opacity, then we won't see the red, we won't see the green. Therefore, the box will become what? Blue. Are you getting the point? But if we mix a little bit of
Yes.
the red and a little bit of the green and a little bit of blue, then we will end up with a different color. If we dim the red completely and dim the blue completely, then the box will look green. Are you getting the principle? We'll come back on this topic a little bit once we start discussing CSS or we start discussing coloring and so on. The idea is
Okay.
that these three colors will always come and be mixed at a particular density inch to get other colors. So in case the rest is absent, then you end up with one. So if you mix them to their highest possible, then it will end up being white. Remember, if you mix all the red, green, blue together to their highest opacity or density, you end up having a white box. Okay? The proof is this. Let's search for color wheel. I think you did that in the school as well. So we'll take only the primary colors, not to worry ourselves much. Which one can I take? So one with clear distinction. So let's take this one for example. Okay. So these are the primary colors we have here, which is red, green, blue. Well, this is the green here, so red, green, and then the blue. And if we have a lot of blue, okay, let's assume when we are mixing them, okay, looking at this, the drawing on the side here, each one of them will have a value. So if you are, let's say the red can go from 0 to 10, the green can also go from 0 to 10, and the blue can go from 0 to 10, right? I was saying that if we assume we give these colors, if we give these colors some value, okay, the red we give it from, it can take values from 0 to 10, the green the same thing from 0 to 10, the blue the same thing from 0 to 10. So if we decide to say we want to mix 0 of red, 1 of the green, and then maybe 10 of the blue, you can see that the final color we are going to get is definitely going to look bluish, or some blue close to some green, right? Because there's some one green inside.
Yes.
That's the same principle. So the final color is what is reflected in the square. You get a point?
Okay. Okay.
So let's assume we have one pixel here. So it is red, green, blue, right? So I'll take some of the red. Sorry.
Yes.
Let's assume this is my red. I don't have much red. So we say that, okay, red will take from 0 to 10, right? So right now, I don't want us to add any red. So red is going to be 0. So R is 0. Then the green, we want to have some value. So the green is going to be, let's say, some 5. So it means we can, let me reduce the thickness so that it looks small. Okay. So this is some 5 of green. Then the blue, we want it to be full, so we give it the value of 10. Then I will make it look thick. So you see, kind of you have less green, no red at all, but something that looks bluish rather. You get a point? But the idea is whatever the screen is rendering, it's not inside one pixel it happens. It is a combination of many of these pixels that make up the screen. And each one of these pixels can take a portion of the image that is being rendered. Did you hear me? Did you?
I can't see the screen. No.
You can't see the screen, eh? Oh goodness. I didn't share the screen. It is shared. You can see. You should be able to see it. It is.
Okay. Now I can see.
Okay. So this is the pixel I just did. So that's the mix.
Now I can see.
Good. So I mix 0 of the red, 5 of the green, and then 10 of the blue. Sorry. I think the blue is B, not this. Good. It's blue. So by doing that, you see we get something that looks bluish because the blue is more. So I was saying right now that the idea is that the screen does not render our pictures inside one pixel. It combines many pixels. So if you see a picture that looks blue on your screen, then most of the pixels that contain or that are shaping that image are having more of the blue on them. So if you are to draw something on these pixels, definitely it is going to be a blue thing because most of the pixels have taken the blue shape. So that's how it goes. So all the pixels will kind of share your picture. Each one will take a portion of your picture. Wherever there is green, it shows green. So if we take a picture like, let's say, horse, we search for a horse, right? So whenever I'm displaying this picture on my screen, let me open it on a new tab and then get to zoom it up. Okay, I opened something else. Let me open the image itself. Good. So right now, as my screen is rendering this image, right, this area, I don't know if you can see this area of the dress where the dress is yellow here. So all the pixels that are inside here, I've created the yellow, I've carried the yellow value. So which is a combination that came from this. You can see this value here. So if you take the primary colors here and then we mix them a little bit. So if I think because we have RGB, so we have to mix to get the yellow. So it means we mix a bit of the green and a bit of the red to get the yellow, right? So here, all these yellow areas, it means there was a mix of red and green, and the blue was completely cancelled. The same thing here. If we have a blue here, it means the red and the green were completely cancelled in this area on these pixels that are around here. So everything you see here, the pixels have shared the whole image, and each one of the pixels will render a color that will match the picture, the reality of the picture. And that's what gives us all these beautiful images. Okay. I hope this enlightens you a little bit on how computers actually render pictures, okay, or anything. And it's not only about pictures, it also applies to text, okay. Even the text, you can see some of the text has blue, some are white, some are black. So it's the same thing. Are we okay?
Yes, please.
Good. So with that out of the way, we can now discuss the mouse. Unless you have a question or an addition you want to make.
No, please.
All right, thank you so much for the understanding. So the next thing is the mouse. The mouse is kind of the representative of our natural hands inside the computer. Okay, the mouse represents our hand because the screen not only it gives us a feedback. The feedback it gives us is not a dead feedback. What I mean by dead feedback is a feedback where you just have to read and then go. No, it might prompt you or require that you take an action for subsequent operations. Okay, so in our case, for example, as we are using the computer, I am using it to show you something. I need to be able to draw and then let you feel my hand, let you feel the work. So the mouse primary goal is to allow us to represent our hand inside the computer because the hand is used in making choices and decisions. So in choosing what we want on the screen or where we want the computer to do something, then we use the mouse to make these kind of indications. Okay. So if I want the computer to minimize this thing, then I will move the mouse to a particular location where it indicates to me that, okay, if you want to minimize, use this one. So when it says, it gives me these buttons for these various operations. At the same time, it expects me to use my mouse and get to that place. Oh, my student wasn't there. Hello? Welcome back. I was talking alone. I didn't know you were off. Can you hear me? Good. Can you hear me now?
Yes.
This internet is worrying you today. Oh.
Hmm.
I'm really sorry. Don't worry. Don't let that offend you or affect your mood. I am completely here for the class, okay? If it wants you to go, it should go off 10,000 times. We are waiting. So there's no wahala. Okay, so I was explaining that the mouse is like our representation, the representative of our hands, our human hands or natural hands.
Oh.
Easy. Take it easy. Can you hear me now?
Mm-hmm.
Good. So if the mouse represents our hand, it's like basically what most of the things we can do with our hands naturally, we could achieve the same things or at least close to the same things inside the computer, and that's the purpose. So anytime the screen or the computer gives us a feedback on the screen, it makes places for us to take decisions, for us to make choices and let it know anything for its further actions. So for example, in this case, it displayed this software right in front of me, which allows me to draw. But at the same time, it gives me buttons to say, okay, if you want to draw, use this button and then make the drawing. If you want to close this screen or this interface you are seeing, use this button to do that, and so on. So it gives me all these locations, all these places, and all these tools to allow me to make choices and decisions, which also will indicate to the computer what to do next, right? So we use the mouse to make these indications to the computer. Although we have the same access on keyboards, but the mouse is sometimes and in most cases more practical and easier to do. Okay. Okay, so I was explaining the mouse as our representative in the screen and so on. So it allows us to make choices and decisions on and give feedback to the computer through the screen. Okay, since the screen is the interface between us and the central processing unit, which we know is where everything happens. So the screen is just an interface, a feedback tool. So anytime the computer gives us a feedback and wants us to say to take any action or make a decision, then it gives us places and locations where we can make these kind of things. And I was giving the example of this whole interface we are seeing right now on my screen. That's if you are seeing my screen. Good. So,
I'm seeing your screen.
so the interface is a feedback of the computer. It happened when I click on the logo of the software and the software opened. Once the software opened, the computer tells me, okay, this is the software you requested. And the software has these buttons. It says that whenever you want to draw, click this and then just drag and make your drawing. If you want to minimize the software, click on this one and then it will minimize. If you want to bring it back, just click on the icon and bring it back. You want to just shrink it, just do this, it will shrink. If you want to enlarge, and so on. So we use the mouse to make these decisions. So primarily the mouse comes with two main keys, right? Two main keys. The first key is what we call the left click. So because the mouse is actually in this shape, not really. Good. My mouse is some kind of ugly. So it comes in kind of this shape with a cable. And then we have this area here, which is usually clickable. So this particular partition here is usually clickable, and the other side too is usually clickable. So this area here, it corresponds, it is in the direction of our left hand. So that's why it is called the left click. And the other one is in the direction of our right hand. So that's why it is called the right click. So depending on the click you make, the mouse works differently. So the left click is mostly the click we make when we say, I want this on the screen. I want this. I want this. So this is the one thing. Okay. This is the one thing. And then the right click is mostly to give us more details. It's like asking the screen, give me more details about, or give me more options about something. It's mostly what it does. Okay, so if I do a right click on this guy here, it won't do anything because there is no more details to talk about. There's nothing there. If I do the right click on this empty space here, the screen tells me, oh, there's something else you can do around this software. You can copy, you can paste, you can select all, and so on. You see? So that's the primary difference between the left and right click. So the left click is mostly what you will be using every time you are working. And the right click, once in a while, you might use it for more details. But nowadays we have what we call enhanced mice. So these modern mice come with more buttons around depending on the brand and the design and so on. But generally one common pattern that appears is to have a wheel on top here, a tiny wheel like mine right now, which you can use for scrolling. So it is a shortcut for scrolling. Mostly while we are browsing, we'll have these scrolling bars here like this. So instead of me to be dragging it and scrolling, I could use the scrolling bar from the mouse and then do that. And some of these mice too come with additional keys at the side like this, either to help you go forward or backward. So like if you are browsing, you can decide to go backward or forward. So these keys can help in this kind of operations. And also, depending on the software you are using, a mouse button can function differently. Okay, depending on the software you are using, the mouse buttons can function differently. The proof is, if you are using a software called Adobe Premiere, I don't know much about using it, but my small experience with it is that it allows you to use the mouse in a very strange way. So where you expect to have a click, a left click, but you might have to do a double right click or some long right click and so on. So the shortcuts behave differently. Yes. So this kind of software, you have to learn them. They have gone beyond using the mouse in a traditional way. Okay. So I just want to call your attention on that. The mouse can have a strange behavior from one software to the other. So that's the primary thing. Then another thing we might usually meet is that if we decide to invert our mouse, we turn it back. So this is the back of the mouse. Okay, so I will mark 2 lines here to mark the back. You might have something here, either an optical device which shows some light, and this light is used to coordinate the movement of the cursor of the mouse on the screen. Okay, and it can be a wheel, it can be a ball, some kind of metallic ball that is rolling, but nowadays it is optical. So you see some lenses here, and then it usually brings some beautiful lights and so on. Okay, but mostly it is used for you to coordinate the mouse's cursor. And that brings us to the last aspect about the mouse, the cursor. The cursor is actually this element that is moving when I move my mouse. So it's the actual mouse, the virtual mouse pointer you see on your screen. That is called the cursor. This one is O here. It's cursor. Okay. So all this guy you are seeing moving right now as I'm moving is the cursor. And the cursor too can have different shapes depending on the context or the customization of the the user, sorry. So if I have them, right now I am on this browser. So the cursor changed. It is now looking white, arrow pointing up. And as soon as I start highlighting the text, you see it kind of changes for some few seconds or into, depending on the context, into a bar, like a capital I. So it becomes like capital I. You can see it there. It looks like capital I. And then sometimes it turns into the actual arrow. Exactly. So the mouse can change its shape depending on the software, the context, and what we are doing. Okay. So these are the few things we can say right now on the mouse. Now the keyboard. Normally, if we were to have a face-to-face class, then the keyboard would have gone deeper about it. But mostly, it's the primary input element we use. So mostly, it's the primary element we use to input anything in the computer, right? Whatever we input or any discussion we have with the computer, where we have to provide something, if it is not from the screen through our actions with the mouse, then we'll have to use the keyboard and make that happen. So the keyboard is the primary entry point when we are using a computer. And it comes in different shapes as well, different brands, different designs, and different configurations. But some things are common to them, which is the alphanumeric keys and the alphabet keys. So you have this set of keys that are right in the middle of the keyboard. So if I allow myself to draw some crazy keyboard here, let me use a different color. So mostly around this area, you have alphabets from A, Z, Q, but the order is not A, B, C, D. It can start with Q, W, E, R, T, and these keyboards are kind of called QWERTY keyboards. In some cases, in the French word, you can see it starts with A, Z, E, R, T. So it is called AZERTY. So it differs. In Germany, you might have a different one, and so on. But one thing is common: every single letter is around in that area. Then, right on top of these letters, you have a row of keys which contain numbers from 1 to 9. Oh, 0, sorry. From 1 to 0. So after 9, you see 0. These keys are very important to us. Whenever we want to write a number, we use them. And if you want to write letters, we use these ones here. And then right at the bottom, somewhere close to the letters, you have some few keys around here that are important to us. You have the enter key, which is the fattest key mostly on the screen. Then you have some other keys which are like Alt. It is written Alt on it. Some it is written CTRL, which is control. These keys are very important for our work. We'll get the chance to explore the keyboard more once we meet again, but for now let's go take it this way. And then at the left side as well, you will see these similar keys. We will have Control, Alt, and so on, and then another key called Shift, and so on. So the control keys are mostly used in combination with other keys to make operations. The Shift key is used to enable capital letters, or sometimes to create some special shortcuts depending on the software to do something. And you also have a cap lock key, which is close to the Shift key at the left side, which allows you to turn on the caps. So when you enable the cap lock, it means anything you are typing is going to be in capital letters. I'm kind of brushing on this particular topic because I'm assuming you have a good understanding of using your keyboard, right?
Yeah.
Good. So if there's anything that is not clear here, let me know and we can take our time on it. So then right beneath all these keys, you have this long key which is used for spaces. So it's the space key. Right? So mostly these are the keys we'll be using. Now, in this area, there are some strange keys that also we'll use once we start coding, like the less than sign, the greater than sign. So I would like you to take some time and explore these keys. Open any software, see how you can get the keys to appear, how you can get to write these keys. That is your first assignment. Take your time, open a notepad, right? A note software like this. Note. So open notepad like this and try to see, like, okay, how do I get this character to appear? How do I write this character? Right? So you explore these characters on your keyboard to be able to to master, like, okay, I know how to get this character to be written or not, because you never know when you will be required to write this character. And one assignment I would like to give you on this assignment, so assignment and under assignment, don't forget it. Note, that's your first assignment, is to explore your keys, your keyboard. Okay, so one good assignment inside is for you to write the euro character, the pound character, dollar character, percentage character, ampersand, the hash character, the art character. Anyway, the art is a play, but try to see. And then you have some of the keys on your keyboard that have more than 2 characters on them. You know, when there's a key has more than 1 character, to get the second character written, you need to combine the Shift key with that key. Okay? Yes. So in some cases, some of these keys have more than 2 characters. So in this case, how do we get the third character? So I want you to explore that aspect and see how best you can get it based on your computer. Okay?
Okay.
Good. First assignment noted. So next, if you don't mind, unless you have a question, we can explore a little bit more, but otherwise we can continue to the actual BABA, the system unit itself, which is our most important part to us as computer scientists. Okay?
Okay.
So the system unit usually is the box or the base of your laptop. That base which lands on the desk, on which you have your keyboard, your mouse, and you can use your hand and put on it and then work on the computer. Mostly that's the system unit. And in the case of a desktop computer, it is quite easy to distinguish it. It is a giant box with some buttons and lights hanging there. So that's the system unit. So we went down to dig and find out that inside the system unit we have some other components that are very important. And you mentioned a few, which is the CPU, the RAM, and then the CMOS. So another core one is the motherboard. So I'll call it MB, motherboard. So the motherboard is the main circuit inside the system unit on which we have all the other components mounted. Okay, here you have the CPU, and then somewhere here you have the RAMs, and so on. So all these elements connected in with wires and so on, and that makes the motherboard. It is a board, but because it is called motherboard because it's the primary board that kind of holds everything together. So it's like to say primary board or the core board. So we are interested in the motherboard because that's where the computer functions properly. That's where the computer actually does all the operations. So we want to understand the computer, so it is important to understand a little bit of the motherboard. It is important that we kind of see what is going on inside the system unit. So it is important for us to see what is going on there, what is what. Okay, so the CPU, which is the central processing unit, okay, is actually like a giant circuit, but this circuit does something interesting, which is calculations. So basically, whenever you enter a number inside the computer through your keyboard or any other mean, see it as these numbers will be pumped inside the CPU, and then not only the numbers will be pumped, the operator too will be pumped. So let's assume you press 5 plus 5, so it will be pumped 5 inside with the plus sign, okay, and okay. The two fives will be pumped inside, and then the plus sign too will be pumped to say, okay, do the calculation of 5 plus 5, and then in return the CPU will push out whatever it gets as a result. So you see, the concept of input and output did not start just on the keyboard or the screen or the mouse or the printer. It's right in the core of the computer system itself. The central element of the computer, which is the CPU, works in this principle of input and output. Except it outputs on the motherboard for other components to use the result and so on, and other components coordinate together to bring in the input to it. So these kind of operations are called arithmetic, right? Yes. So the CPU has these circuits wired to help it make arithmetic operations. So it does arithmetic operations. Sometimes too, you can ask it to compare if a number is less than another number or greater than another number and so on. So this is also called logical operation. So it does logic. It knows how to tell if it knows how to compare things. That's logical operating. And that's why the CPU has one part of it that is called the ALU, arithmetic and logic unit. Okay. Yes. So there's something in the CPU called the ALU, arithmetic and logic unit. That part of the CPU is very important when we design a CPU. Okay, of course, I've never designed a CPU and I've never been part of it. I hope one day maybe it will happen. But let me speak in that term. So when a CPU is designed, a part is designed which does the arithmetic and logic operations. And nowadays computers, we even have it more complex than what you can think. It goes so deep. Because we haven't spoken about electronics, so we will not go in details about this aspect of things. But I want you to understand that the CPU does these basic operations, very important. And the CPU doesn't know A, B, C, D. What it knows is numbers. So anytime you type your keyboard, all these letters you are typing are transformed into numbers. And the numbers are punched in the keyboard, in the CPU, and the CPU now retains numbers again. So it's up to whoever wants that result to interpret it in his way. So if the screen wants to transform a letter A you typed, it will transform it. So basically, if we consider the ASCII standard, this is an example, you don't really have to understand these things. If you consider the ASCII standard, when you type the letter 65, it is equivalent to, the number 65 is equivalent to letter A. So whenever you type A on your keyboard, the key on the keyboard acts like a switch, right? Like a switch on your wall. So it will just turn on some electricity, and that electricity will travel through the keyboard down to the CPU, and then the CPU will receive the equivalent, the binary value of 65. The equivalent of 65 in binary, and then it will do all the operations it needs and then return whatever it comes. In this case, let's say another 7, let's say it returns 77. Okay, it returns 77. So it is up to whoever needs the result to make the interpretation, whether it will mean a pixel in blue on a picture, or it will mean a beat on a speaker if it is music, or it will mean a letters, let's say Z, if it is a text. So the interpretation of the values the CPU brings out depends on the software that is actually fetching the result. Okay, and that is called data representation. It is very important you note that term. You will meet it. It is called data representation. It is a different topic that we can discuss deeply. Data interpretation and the representation, because it is interpreted and then it is also taken and represented. Okay, so the CPU is in charge of doing this kind of work. Now, it doesn't do it all alone. It does it by having an assistant, I would say, the RAM. And the RAM stands for random access memory. Because while the CPU is doing all these operations, it needs to keep the results somewhere, or intermediate results. Sometimes it does, we ask it to do 5 plus 5, 5 plus 5, let's say times 10. So using the BODMAS operations order, we could decide to say, okay, we'll do the operations, the multiplication first. So once it does the multiplication first, it has to save the value somewhere. So the 50 of this operation must be kept somewhere before it does the addition of the 5. And then the final result will be kept somewhere, which is 55. So to keep these intermediate results or many other operations temporarily, the CPU uses the RAM to store that data and fetch it back whenever needed. And that's why it is important that your RAM is large enough to allow the CPU to store much or be able to retrieve content faster. So as soon as your memory RAM gets full, then the CPU will be stranded because it won't have much to save. And because there's so much that is already saved, there's no longer space to put in. It's like you entering a car. When there's no one in the car, entering the car seems quite easy. So you can go in and out anytime you want. But as soon as 1, 2, 3, 4, 5 people are in the car, then it becomes, excuse me, yes, sorry, yes. You see, adjustments start to happen. So the same thing happens between the CPU and the RAM. If they are not coordinating well, it is a challenge for your computer. Then you start to experience slowness because the computer is trying to take some time to find out how to adjust things and get you up to what you want. And this is a little bit we can say around that. It is important so that you can make informed decisions when buying a CPU, a computer. And then also, because you are a programmer, it is important once we start studying variables and all this, you understand the value of the RAM there again. Why is the memory important? Okay.
Okay.
Good. So far, I hope it is not too much on you.
No, please.
Great. So the CMOS, we mentioned the CMOS. Indeed, it's a small battery that exists in the computer that keeps some of the circuits up. It keeps some of the circuits up because the computer battery can go completely flat, or it might not even work at all, and then we don't have the computer plugged. There is some basic information we want the computer to always remember, like the information needed to start it up, to boot the computer, and also the information around time, like you said earlier, time and date. So this battery kind of keeps these basic circuits that contain this information on all the time. So in a true sense, the computer never goes off. If it goes off, it really goes off for real. It can be challenging. So we try to keep it alive as much as possible. So these are the few things we can discuss at this point when it comes to the computer system. To this point, if you have any question, please do ask before we close.
Good. And I wanted to ask.
Yes.
How do you install Python?
Good. Why are you in hurry? That's our step 3. But since you asked, then that will be your second assignment.
Oh, third assignment.
Third assignment. Yes. So it is not going to be difficult for you. So you go on Init Academy, right? You click on courses. Then
Okay.
the first course you see is Python Basics.
Yes.
This is going to be the course we are going to use along the. So I didn't want you to see it now, but it's fine. So you take your time and read, and then the preamble, you can do the preamble between now and today. I think, no, even here so far, I think this is where I am indicating the installation. Yes, so these are the steps to install. Right in the introduction, you can already have the steps to get Python installed. But if you want, you can also take your time to read the preamble here before we meet tomorrow.
Okay.
Yes, so with that being said, thank you so much, and I wish you to have a wonderful rest of the day.
You too.
Thank you so much. Bye bye. See you tomorrow.
Thank you.
You're welcome.
Okay. What time? Tomorrow what time?
Same time. We keep it the same time, yes. And don't forget your init time to sleep and init time to wake up.
Okay. I'll try.
Try, yes, try. It comes with time. It won't happen in one day. It is a matter of time. Okay?
Okay.
And the importance, in terms of discipline, this is what I want you to have you have to write in your journal today, as the importance of mental clarity. Okay? I want you to write that on your journal, or in your journal, the importance of mental clarity. Okay, and then the principle of cause and effect. You can see that everything we explained today follows the principle of cause effect, which is the input and output, you pressing a key and then having something to reflect, you clicking on something happening, and so on. So you could see that it is basically natural laws that are being expressed scientifically. It is important for us inventors and creators to understand nature, to understand how nature already gives us secrets and clues on how we can build and create, right? So probably you
Yes.
might have heard in church or any other organization that there is a principle of cause and effect. Mostly people will talk about it when they discuss karma. They will be like, whatever you do, you will be rewarded for it. So the same principle can be used as a scientist, as a thinker, to create, invent. And this is a clear example of it being used in computers. It right in front of us every day, and we still doubt it. You get that? So you have
Yes,
that
please.
in mind, that it is important to have a clear mindset. Your mindset, mentality has to be clear, because you are a thinker. You don't pollute your mind with talks that do not help. Okay? You should always discuss things that are
Okay.
constructive and helpful for your life. And then another thing you are going to write is to understand how does order in my code reflect order in my life. We'll explain it once we finish with the course tomorrow.
Okay.
Good. So on that note, I salute you, dear initiate. Have a blessed day.